talk about pressure. So pressure is the amount of strain or stress that is put on a system. So let's take a few examples of how pressure you can observe pressure in real life. So let's say you have a steel sheet. Let's say you have a sheet made of any type of metal, and if you put some force on it using your hand or thumb, whatever, then your sheet would start to bend. It would start to bend in some way like this. So in a way, you applying force results in a pressure on the sheet, and it causes it to bend. So let's define pressure. Let's define pressure as a mathematical expression. In that case, you can write pressure as force applied per unit area. Force applied per unit area. So that means if you divide force by the area on which it was applied, it would be equal to the force, to the pressure that force applied. So let's do a quick example. So let's say you had a sheet of area 1 meter squared, and you put a pressure of 50 newtons on it. Then the resulting pressure that you put by your force is equal to 50 newtons over 1 meter squared, and that's just 50 newtons per meter squared. Now there are many units for pressure, but let's start with the SI unit first. Let's talk about the SI unit, since it is necessary for you to understand the SI unit first. To understand other units, we will just start with it. So the first thing that you should keep in your mind, that the way to make an SI unit is by using SI units. So what do I mean by that? Let's take the example of pressure itself. So pressure, to get the SI unit of pressure, you use the SI unit of force as well as area. So the SI unit of force would be newtons, and the SI unit of area would be meters squared. So newtons per meter squared is the SI unit for pressure as well. And this is also known as a Pascal. A Pascal, named after the scientist Blaise Pascal. It's called the Pascal. So the Pascal is the SI unit for pressure, and 1 Pascal would signify something equivalent to a force of 1 Newton being applied on an area of 1 meter squared. We also have some other units, and one of them happens to be, if you take force in pounds, and area in square inches, then what you get is the unit PSI, pounds per square inches. That's called the PSI. Now, the first exploration of pressure came up right after a scientist by the name Evangelista Torricelli conducted his experiment in the 17th century Europe. And what he did was really innovative. So what he did, he took a container, and filled that container with a metal liquid that we know as mercury, the same mercury that's used in thermometers. He used that to fill up this container. What he did then is he took a test tube, or a glass tube for that matter, and he sucked all air out of it and put that tube directly into the beaker. He put that tube directly into the container, not necessarily a beaker. And once he did that, then the mercury started to expand into the test tube. It resisted the gravity. Instead, it started climbing upwards into the test tube. So let's say that the mercury rised up to certain length within the test tube. And he measured that length, let the length be L, and he measured the length L, and he found it to be 760 millimeters. And you can write that in different units as well. This will be equivalent to writing 76 centimeters. This would be equivalent to writing 0.76 meters. But sort of 760 mm still remains the standard for writing this pressure. And since this pressure is derived from mercury, today we know this pressure as 760 mmHg. So mm standing for millimeters that it rises, and Hg being mercury. Hg is the symbol for mercury. A couple of quick notes though. This 760 mmHg arises due to certain phenomenon known as the atmospheric pressure. And the atmospheric pressure is really simple to understand. So we are surrounded, the Earth, let's say the Earth, roughly a sphere, is surrounded by atmosphere. So it's surrounded by atmosphere, gases, and all stuff of different things. And that atmosphere applies a pressure on us. It applies a force, and thus it applies some pressure as well. And this atmospheric pressure is equal to what Torricelli found in his experiment. Why? Since atmosphere applied pressure, these white arrows that I'm showing, represent the pressure that the atmosphere would have applied. And since there was no pressure being applied by the test tube, it was all vacuum, I said in the beginning, then the pressure from the atmosphere forced the mercury to resist gravity and flow up into the vacuumed tube. Also, the 760 mmHg doesn't stays constant for wherever you conduct the experiment on planet Earth. It depends on a lot of variables. It depends on how far you are from the seaside. Let's say you climb up on a mountain. Then on the mountain, there is less of atmosphere than it's available on the surface, on the sea level. So the 760 mmHg would be expected to dip a bit. Let's say it would be 750 or 740, or let's say you were at Mount Everest, on the peak of Mount Everest, it would probably be 700 only. However, the idea still remains the same. This truly innovative experiment still remains the gold standard for the first time when humans came to know about pressure being exerted by the environment. Now, it also, not only does it depend on environmental factors, it also depends on the type of mercury you are choosing. It depends on the temperature of the mercury, it depends on the density, and there seems to be one more unit that's called 1 torr. And 1 torr is an mmHg measured under certain conditions, namely most substantial being taking 1 torr to be equal to 1 mmHg at 0 degrees Celsius or 273 Kelvin. And while 1 torr is still used, mmHg still seems to be the de facto standard for measuring temperatures, for measuring pressures, especially the atmospheric ones. There are also certain other units when we talk about pressure. And first of all, let's even before even talking about them, let's convert this rather non-SI unit. mmHg is not an SI unit. It was not described as the de facto unit by Système International. It's when you convert it into SI units, you get the following conversion: 760 mmHg, or roughly the atmospheric pressure applied by the atmosphere near sea level, is equivalent to a pressure of 101325 pascals. And if you write that in if we write that in scientific notation, then that would be equal to 1.01, roughly 1.013 into 10 to the power 5 pascals. There is also one more unit, this being the SI conversion. This is the SI unit. The second one is called ATM, atmospheric pressure. Really simple. So it's 1 ATM is defined to be equal to 760 mmHg, and it's as simple as that. Since we are talking about atmospheric pressure, they chose to name the unit after it, and this stands for atmospheric pressure. 1 ATM is equal to 760 mmHg. Sometimes in books, you also encounter a unit called bar. And one bar is just equal to 100,000 or 10 to the power 5 pascals. 10 to the power 5 pascals or 1 bar is one and the same thing. And you can also write 10 to the power 5 as 10 to the power 2 times 10 to the power 3 pascals. And since 10 to the power 3 is 1,000, and 1,000 pascal can also be written as 1 kilopascal. So 1 bar is equal to 10 to the power 5 pascal, which again is equal to 10 to the power 2 or 100 kilopascal, kPa for short. And you can substitute this conversion of bar into pascals or pascals into bar, whichever side you take it. Then you can write this 10 to the power 5 pascal as a bar, and you will get 1.013 bars. So till now, what we have done is we have learned a bit about what pressure is, how force resulting on a certain area gives you the pressure applied. You've learned a bit about the units, pascal, pounds per square inch. We learned a bit about the Torricelli's experiment conducted in the 17th century by the brilliant scientist, and we learned a bit about the standard convention that goes on in science. So you have ATM, you have mmHg, you have pascals, you have bars, you have kilopascals, you have psi, and you also have torr. Don't forget torr. So let's do a quick example before ending this video. Let's say you have 1.20 bars. Now 1.20 bar is equal to 1.2 into 10 to the power 5 pascals. 1.2 into 10 to the power 5 pascals. So using unitary method, what you can do is, I want this bar to be converted into ATM. I forgot to mention the problem, so you have to convert bar into ATM. So we do know that 1.0135 into 10 to the power 5 pascals is equal to 1 ATM. So 1.20 bars would be equal to what? And so you can use that unitary method, and what you'll arrive at eventually is the following conversion factor, and that would be 1 ATM over 1.013 into 10 to the power 5 pascal. And once you solve for this, so pascals cancels pascal, 10 to the power 5 cancels 10 to the power 5, and you are left with, once you compute this, you are left with 1.18 ATM. Now, if you want to convert this 1.18 ATM into mmHgs, so we know that 1 ATM equals 760 mmHg, so 1.18 ATM would be equal to 1.18 into 760 mmHg, the product of the two, and that's roughly equal to 900 mmHg, or 9 into 10 to the power 2 mmHg. So hopefully this video has strengthened your understanding of pressure and its units, and I'll see you in the next one.